Hello everyone, welcome back to Educlynk. So now we are solving the second question under the topic of conjugal access about two program. So the question goes by, given this is what we are given, our example space or readers assets, and we're given data like this, you notice you see that it is all of the given numbers from 1 to 20 inclusive, because 20 is there. And B is all of the multiples of 3 from 1 to 22. So the A part says find A and B, B part says find A intersection B, C part says find A prime, D part says find B minus A, and the E part says find the, this thing, how do you read? This one means it does not mean find A and A prime. It means to find a number of elements that are found in A and B prime. So for this you have to find A and B prime, then you find the number of elements in it. And then here are A and B disjoint sets. Explain your reason. So let's start. So A says you should find A and B. This is A, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Union B. So what does it mean? You write all of the tens that are found in A, all of the tens found in A, and all of the tens found in B one time. So if you find a 10 which is found in A and in also B, you write it one time, you don't write it twice. So that's your A and B. So actually, what is the formula for A and B? A and B is equals to, I think it is here. Yeah, A and B is A plus B minus A intersection B. What does that mean? It means A and B is everything that is in A, you write it, plus everything that is in B. It means you write all of this, then you write all of this in one set, then minus A intersection B. So you see that A intersection B is, for instance, 6, because 6 is in A and 6 is in B. For instance, 12 and 18. So since there are two, the minus A intersection, you remove one of it so that you'll be left with 1. So what's the formula there written? So what does it mean? You're taking all of the values. I will recommend to take them from, in ascending order, from the smallest to the biggest. You write them from the smallest to the biggest. So the smallest here is 2, then 3, right? 3, then 4, then there's no 5, it's 6. You see there is 6 here and here. But I don't write 6 2 times, I write 6 1 time. Then there's no 7, there is 8. There is 9. There is 10. There is no 11. There is 12. There is no 13. You see, it also repeats, but I write it 1 time, I don't write it 2 times. There's no 13, there is 14. There is no 15. There is 15 normally. There is 15, like you have seen in the equation, there was 15. There's an error, I can put 15. So there is 15. Because 15 is a multiple of 3. There is 16. There is no 17. There is 18. There is no 19. And there is 20. So this is A and B values. Instead that you compare all of the terms here and here. All of the terms appear there once. Just once. Only once. There's no term which will appear there twice. Even if it appears in A and B, it appears just once in A and B. So, what is B saying? A intersection B. So what is the meaning of K intersection B? If you go to set operations note, if you see here equation 2, it's inside set operations. If you go to set operations, so this question is dealing with everything that was done on that set operations. You see all of these operations there. What is A intersection B? What does it mean? It means everything that is in A that is only found in B. So everything that is in A and in B. You get that is A intersection B. So in this case, what is A intersection B? 3 is found in B. Is 3 found in A? No, I don't write it. 6 is found in B. Is 6 found in A? Yes. So 6 is found in B and A, or in A and B. So I write my 6. None is found in B. Is 9. 9 is found in B. Is 9 in A? No, I don't write it. 12 is found in B. Is 12 in A? Yes. This is 12, so I write it. 15 is in B. Is 15 in A? No, it's 15. 18 is in B. Is 18 in A? Yes. I write 18. And that will be hard. So it's the common terms to A and B are 6, 12, and 18. That is B intersection B. So the C part says A prime. So how do you find A prime? A prime means everything that is not in A. Every other number that is in your epsilon, near zeta, which is not in A. Even if the term is in B. But it should just not be in A. So A prime percent is just 8. You don't really care about B. Actually, A prime means you should write all of the terms which are in zeta, but not in A. What are the terms that are in zeta, by the way? They have given us a stat, a descriptive method. So it'll be a zeta. Right. We said zeta is x such that 1 is less than or equal to 8 is less than or equal to 20. This means 1 is in between, x is in between 1 and 20. Inclusively because of the equal to. So when you see the equal to sign is the 1 there and it's considered. If you do see this equal to sign, it means x is 1 is bigger than x because 1 is smaller than x. It means x starts from 2 because it shows you that 1 is smaller than x. So x will not start from 1. But if it is equal to yes, x will start from 1 because 1 is smaller than or equal to x. So you have to, there's certain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is our universal set, our sample space, our ancestor. Okay, so A prime means everything that is not in A, which is found in our universal set. So you check here. Okay, you check here in your universal set and see if there is anything in this universal set which is not found in A. If that is the case, you write it here. But if it is found in the universal set and also is in A, then it is not A prime because A prime is not A. Everything which is not in A. So you should write every number part numbers. So let's say K is 1 in A. No. So since 1 is not in A, I write 1 there. Is 2 in D? Yes, 2 is in A. Is 3 in A? No. I write 3 here. Is 4 in D? Yes, 4 is in D. Is 5 in D? No, I write 5. Is 6 in D? Yes. If you notice well, all the values are in D are even numbers from 1 to 20. So if you notice it, you can just write all your odd numbers. Because if a number is not even from 1 to 20, then it is odd. So I can just write all your odd numbers. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19th. You see that all of these values are here, but not in A. And those are the values of our wiki. Values that are in our zeta, but not found in A. So some people might say that this 5 or this 9 is found in B. What do I say? Well, it can be found in B, but it's still writing. Because A prime does not concern B. It concerns just A and zeta. So A prime means everybody which is not in A. It might be in B or in any other set, but it should not just be in A. And it must be in a zeta. So yeah, I cannot come and write 21.385. Because when zeta ends at 20, that's my sample space. That's where I stopped with. So I cannot put my 21, 23, 25, and 7 because they are odd numbers. So where this one starts, I start there. Where it ends, I end there. Okay, so I'm at D. D says B minus A. So what is B minus A? It means when you look at B, you remove from B everything that is in A. It's just like subtraction. If they say 3 minus 2, from 3 you remove 2. They're going to be left with 1. The same here. B minus A means from B you remove A. So this is B here. From this B, you remove everything that is in A. So we are seeing 3. Is 3 in A? No, so we don't remove 3. 3 is going to be there. You are seeing 6 here. Is 6 in A? Yes. So since 6 in A, we remove that 6 from here. So it subtracts. So we don't put the 6. We have removed it. We will cancel it. We check now. 9 is in B. Is 9 in A? No. Means it is not removed because it is not in A. So it's in B. Is so in A? Yes. So I cancel it. I remove it. In fact, let's check first before going to write there. This is 15 in B. Is 15 in A? No, it is not 15. 15 is not in A, so I don't remove it. Because it is not found in A. If it is found in A, I'll remove it. 18 is in B. Is 18 in A? Yes. So I can remove 18. Or let me that way. 3, 9, and 15. So you see here that when I remove the terms in A from the terms in B, I'm left with 3, 9, and 15. Because I've removed all of the other 10 which are found in A from here. 6 is when we get removed it. 12 also and 18 also. So that's just what it means. A minus B or B minus A in that case. So that is it for D. The E part says n of A union B prime. N of A union B prime. Is it here? Here are pen of B union B. So I ask you for pen of A union B prime. Notice that these formulas without the n are still correct. So if the address A union B is equal to A plus B minus E intersection B. So whether if you put the n or you don't put it, the formula is correct. So it is correct for number of elements inside and also for the elements themselves. So this one means what is the number of elements found in A union B prime. So what do you have to do? First you have to find A union B. When it's A union B, you helix as all of this. We will not copy it back at A union. Now A union B prime is what is here. How is A union B prime? A union B prime meets all of the values which are not in A union B but are in zeta. So we should not write any of these values here. So we should find the other values which are not written here which are in zeta. So what are they? We have to 1. 1 is in zeta, 1 is not here. So I can write my 1. because it is not found in A and B. So A and B prime means numbers which are not found in A and B, but which are in a zeta. Yeah, universal sets the sample space. So you have 1, 2, 2 is there, 3 is there, 4 is there, 5. I'm not seeing 5 here. 5 is there. Sorry, I had my 5. 6 is there, 7 is not there. There is no 7 here, so already it fell. If you check where they will be, okay. Let me not talk. 1, 5, 7. Let's continue. 8 is there, 9 is there, 10 is there, 11 is there. 11 is not there. There's no 11 yet. Sorry, there isn't. 12 is there, 13 is there, 14 is there. 13 is not there actually. There's no 13 here. Sorry, 13. 14 is there, 15 is there, 16 is there, there's no 17. 18 is there. There is no 19. Is there 19 here? No, there is no 19. I'm doing 6 there. First should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So what I wanted to say before stopping myself, if you notice, these are all prime numbers in this range. Well, they are not all prime numbers. 2 is also a prime number, it is not found here. 3 is also a prime number, not found here. 5, 7, 11, 13, 17, 19, they are prime numbers. Okay, so they're asking for the number of elements now. Because this is A union B prime. So they're asking for the number of elements found in A union B prime. How many elements are there? 1, 2, 3, 4, 5, 6, 7. When you write this 7, you don't write like this. You miss this is set. But you're asking for a number. So write the 7 lows notation. So then is it just like that? So what does the S part says? What does it say? It says, are A and B disjoint sets? Explain your answer. So that disjoint sets. Disjoint sets are sets which have no terms in common. Like the intersection of A, in this case is A and B. The intersection of A and B is a noun set, it's nothing. So you don't have no one set in common. Are they disjoint? No, they're not disjoint because they have 6, 12, and 18 in common. So the answer here is no, they're not disjoint, and the reason is because there are some sets in common. That is it for question 2. You see, this question deals more with a set of operations. So that's all actually more get understood. Now we are going to do question 3. So hope you will watch it. Question 3 on the says. So come now to then keep on solving with us. I'll peace.